And it says find the zeros. So here you have f of x equals x cubed plus 5x squared minus 87x minus 91. Okay, there's our polynomial function. And if you're looking for the rational zero, applying the rational zero test, you have your factors of 91. 7 times 13 is the prime factorization of 91. So we have P over Q, and we have plus or minus 1, plus or minus 7, plus or minus 13, and plus or minus 91. Okay, basically you're going to have all the prime factors, and then all the multiples, different possibilities of multiplying them. So your possible rational zeros are 1, 7, 13, 91, along with the plus and negative. And let me show you, let's just go into Desmos. So by the way, graphing calculators are very useful for this stuff, but if you don't have a graphing calculator, I always design my tests so that you don't need a graphing calculator. I try to make my tests very conceptual, and I'll provide graphs on the test. So if you feel like, oh, I don't want to spend $120 or whatever it is to get a graphing calculator, you'll be fine. But some people find it very helpful to have one. So it's just kind of your call what you want to do with that. But my function here is, so a lot of people who teach this class, they require a graphing calculator, but I don't like to do that because you can learn this stuff just as, I never used a graphing calculator when I learned it. So, it's possible, but it's up to you whether you want to do that or not. So here I'm graphing this thing, and let's see, obviously I can't see the zero, well, there they are. Here we have one at negative 11.747. Here's another one at negative 1. And here's another one at 7.747. So they're, and this is a degree 3. So those are the only real, there are no complex zeros because we've identified 3 x-intercepts, and therefore there are 3 zeros. Can you guys see this out there in Zoom? Yeah, looks like you can.
Wait, why is there a negative 1?
Well, let's do this problem. Let's actually find the zeros. So we have our list of possibilities, and we can see one of the rational zeros is negative 1. Okay, we can see that right there. The x value is negative 1. So let me go back to the problem. And there, negative 1 is in our list there. So if I use synthetic division, I know that I'm going to get 0 as a remainder, right? Because I already know that this is a 0 based on the graph. So 1 times negative 1, negative 1 times 4 is negative 4. Negative 1 times negative 91 is 91, and that's 0. So what does this mean? This means that my function f of x is equal to x plus 1 times x squared plus 4x minus 91. Now, the negative 1 comes from this factor, right? The other 2 zeros come from this. Well, how do I solve this? Well, I'm looking for zeros, so I'm looking for the solutions to this equation. X squared plus 4x minus 91 equals 0. And to solve this, because I want to find what x values give me 0 when I plug it in. To solve this, I use the quadratic formula, so that becomes minus 4 plus or minus the square root. B squared is 16 minus 4 times a is 1 times negative 91 over 2 times 1. And let's see, 4 times 91 is 364, plus 16 is 380. So x equals minus 4 plus or minus the square root of 380 over 2. And if I do the factorization of 380, I get 38 times 10, 2 times 5, 2 times 19. So this becomes minus 4 plus or minus the square root of 2 times 2 times 19 times 5. I can only take these two out. So I get minus 4 plus or minus 2 square root of 95 over, because 5 times 19 is the 95. The 2's come out as 1, 2. And then these two each have a factor of 2, and I'm dividing by 2. So this just becomes minus 2 plus or minus the square root of 95. And if I do the calculate, well, if you take minus 2 plus the square root of 95, you get 7.747. And if you do the other one, you get negative 11. So negative 2 minus the square root of 95 is negative 11.747. So those are your 3 solutions. Did I lose my Zoom session? Oh, I guess I didn't share my screen, did I? Anyway, there we go.
That was just to test it, really.
What's that?
That was just to test it, make sure it was,
Test what?
excellent stuff.
I'm sorry. We're supposed to find the real zeros or find the zeros. I probably didn't specify that. So let's review what we did in this problem, okay? The problem is to find the zeros of my polynomial here. So I want to know what the possible rational zeros are. So I apply the rational zero test and I narrow it down to 8 choices. And then I went out to Desmos and I didn't even need the rational zero test. I just found out that -1, based on looking at the real number line, the x-intercepts, -1 is a real zero, and I verified that with the synthetic division. Once I found that, remember those other 2 were the -11.74 and the 7.7, whatever that is. So I used the quadratic formula on this because I'm finding the zeros. So I set this equal to 0. I'm solving this equation here using the quadratic formula. So my zeros are -1, 7.7, I think that's a 7.747, and -11.74. Hold on, let me just check that real quick. 11. Yep, that's right. Okay.